finishing up with 3.1 on those exponential functions. We're going to talk about two types of interest. We're going to talk about compound interest, and then I wrote out some nastiness for you guys, and then we're going to get onto some continuous interest. So to start with, though, we're going to talk about this thing called compound interest. So I went ahead and I wrote down the formula and like what everything stands for, but kind of want to talk a little bit about what does compound interest even mean, right? So we're gonna make a funny little scenario, and we're like gonna say that you have $1 that you're going to invest. So you have $1 to invest, and you're gonna invest it at 100% return per year. Oop, running out of room a little bit. So ultimately, your interest rate would be 100%. And if we could find interest rate that gave us a 100% return, we would all be rich. So you never get it at 100% return, but it's an easy percentage to work with when it comes to kind of coming up with this example about what compound interest means, right? So ultimately, we're going to look at these just like for 1 year for right now when it comes to this little example to figure out what compound interest means. So if I put $1 into the bank and then I wanted it to stay in there for 12 months, right, for 1 year. And whoop, oh, I hate when it does that. And I'm putting in $1 to start with, right, because that's all the money that I have to invest. So if they're only going to pay me interest once a year, I'm going to keep $1 in that account all the way until I get to 12 months. And then at 12 months, I'm still going to have my $1, but then they're going to pay me 100% interest. And 100% interest on $1 would be giving me another $1. So at the end of the year, I would have a total of $2, right? Picking up on what I'm laying down? So what happens though when it comes to compound interest, we sit there and we don't want them to pay us once a year. We want them to pay us more often. So some people or places might say, well, we'll pay you every 6 months. They're still going to pay you 100% return for the whole year. So all the way to 12 months, but they're going to pay you twice a year. So you're going to get a payment at 6 months. But you're only going to get 100% for the whole entire year. So that means they're going to pay you 50% interest in the first 6 months, and then they're going to pay you 50% interest in the second whole month, right? So for the whole entire year, what percentage are we getting? 100%. So we're going to put $1 in, right? At the end of 6 months, we're still going to have the $1 that we put into the bank, but we're going to get 50% interest on the $1. 50% of $1 is 50 cents, right? So now we have how much money? We have $1.50. So that $1.50 is going to be what we have at the end of 12 months. But then at 12 months, they're going to pay us 50% of the $1.50 that we now have. Anybody know what half of $1.50 is? I think I heard somebody say 75 cents, right? So then now at the end of the year, I now have $1.50 plus 75 cents. I now have $2.25. So that's better than the stick in the eye of above of only we had another quarter, right, than what we would if they only paid us in 6 months. And this can keep going. We can even do it for, let's say quarterly. So if I wanted quarterly, that means 4 times. So that would be every 3 months, right? And instead of, we're still going to get paid that 100% through the entire year, but every 3 months, what percentage are they going to pay us? Yeah, 25%, right? 25%, 25%, 25%, and 25%, right? And when we add it all up, what percentage did we get paid by the end of the year? We still get our 100%. So they're giving us them in those smaller little chunks. So You guys are going to trust me on this one. So I take $1. After 3 months, I'm going to still have my $1, but then I'm going to make 25 cents, right? Because that'd be a quarter of $1. So at 6 months, I would now have $1.25, but they're going to pay me some interest. 1.25 times 0.25. They're going to give me, we're just going to like kind of round this and say 31 cents, right? So then now I have 31 plus $1.25. So now I have $1.56, right? At 9 months, and then at 9 months they're going to pay me 25% on that $1.56. Should have done this math ahead of time, huh? 1.56 times 0.25. So that's going to be another 39 cents, right? Plus my $1.56. So now I have a total of $1.95, but then now they're going to pay me 25% of that, which is going to be 49 cents. And so at the end of the year, I now have $2.44. That's even better, right? So when it comes to figuring out, and then as we sit there and start making those increments smaller and smaller and smaller, because that interest is compounding, so you're getting that interest, and then you're making interest on your interest money, and that's why it's compounding. So that interest money keeps compounding over and over and over and over again. All right. So when it comes to us, and we're going to look at some examples here in a minute. When it comes to compound interest, we just need to kind of go through what all of our little guys mean here. Nope, no erase. Our P stands for, we call it the principal, which would be what we start with. In our example, we are talking about money. So it could be money, it could be weight, it could be population, there could be different things. It's whatever you're starting with is our principal. 1 really stands for 100%, because right now with our compound interest, we are hoping that we are making money. So we have 100%, which is what we started with. And then plus would be the fact that we are gaining or making money. If we were losing money, guess what this would be? This would be a minus, right? R is our rate. So our rate would be our percentage. We just need to make sure that when we are doing rates and we are looking at percentages, if I gave you a rate of 7%, we usually don't put 7% into our calculator. We convert this into a decimal, right? This is 7 out of 100. So this would be 0.07. So that's probably one of the common mistakes that some people make, is they do not convert that percentage into a usable form of a decimal when it comes to the problem. N is the number of times per year. So on this first example, our N would have been 1 because we only get paid once a year. On this one, it's twice a year, so it would be 2. This one, you got paid 4 times a year, so it would be 4. And then T is the years. We only did ours for 1 year, but you could do it for whatever the problem's asking for, right? So if we go back to our little example on how we kept making a little bit more money and a little bit more money. So when it comes to compound interest, I went through and I did this little example, and we started this a little bit. Same thing, we're investing $1 at a 100% and like over 1 year at a time, right? So the exact same thing that we were just doing. Remember, we had the $2, the $2.25, the $2.47. But then I went through and it's like, well, what happens if we got compound interest monthly? So we got paid 12 times a year. So my 1, right? My N, we got all of ours, right? And I get paid, oops, there we go. And I'm going to go through monthly. Sorry, I can't multitask, trying to get people in the room and trying to teach at the same time. So then we got up to 12 months, right? So we got our 1 for 100% because we're making money. So we got a plus in there. Our percentage, because it was a rate of 100%, that would be 1 as a decimal. If that was 7%, it would have been 0.7 up there, 0.07 up there. We're getting paid 12 times a year, and then our N was 12, and our time was 1, so there's technically a 1 there, right? So we get paid $2.61. What if we got paid daily? Oh, we make a little bit more. What about if they sat there and said they'll pay us 1,000 times in the year our interest, or 10,000, or 100,000, or 1,000,000 times? And if we start looking, all of a sudden we start getting to, look at this, 2.7146, 7169, 71814, 71826. These numbers start getting to where they're fairly consistent, right? That 2.718. And that 2.178 is actually a little magical number when it comes to mathematics. That is actually what E stands for. So when we are looking at continuous interest, because that's ultimately what we're getting to, if they're paying us 1,000,000 times of interest in a year, that increment's going to be really close from the time, so it's almost continuous. And if we keep increasing that number until we can get to continuous, we're going to get to that value of E, which leads us to a formula called continuous interest. Okay. Where's my eraser? One of these days I'll get it right. All right. So when it comes to continuous interest, and it'll tell us in the problem if our interest is being compounded or if it's going to be continuous interest. And there is a difference, and you're going to get different values, extremely different values. So a lot of these letters are the exact same thing as what they were when it came to compound interest. P is your principal, so it's whatever number you're starting with. E is on our calculator, right? We kind of touched with that a little bit yesterday. If you have a graphing calculator, it's that second ln, right, which will give you that 2.1728 number. R is our rate, and again, make sure that you're converting that percentage to a decimal, right? To a decimal. And then T is your number of years, right? So on the example that we're going to do, I'm going to put on there if it's compounded or if it is continuous. So that's the words that you're going to be looking for when you are working on your assignments. So let's say you want to invest $8,000. Everybody feels bad for you guys. You guys are all seniors. You're getting ready to graduate. So, you know, your virtual open house that you're going to have, people are going to send you money. And after you added it all up, you ended up with $8,000. And so you decide that you're going to invest that, and you're going to invest it for 6 years. You're going to go, you know what, I'm going to go to college for my 4 years of bachelor degree, and then I need to get my master's, which is going to take another 2 years. So I'm going to take that $8,000 because I got all the scholarships to pay for college. So I'm going to take that $8,000 and I'm going to invest it for 6 years, and I'm going to see how much money I'm going to make. So we're going to do 2 scenarios. So for the first scenario, we're going to say that you get 7% per year in interest. And we're going to compound that amount monthly. Right? So the first question you're going to ask yourself is this compounded or is this continuous? And we're going to read that word, and it says compounded, so we know we have to use our compound interest formula. So that was where f of x equals p times 1 plus r over n all raised to the n times t. Right? So what was our principal? The amount we started with? 8,000. Times 1 plus our rate. What was our rate? 7%, but we know we have to turn that into a decimal. So that's going to be 0.07, right? You can always divide it by 100 if you're not exactly sure where the decimal goes. Divided by n. N is how many times a year they're going to give us interest, and they're paying us monthly. How many months are in a year? 12. Raised to the n, or 12, times our t, which is our time. How long did we invest it for? 6 years. So we're going to get our fancy dancy handy dandy little calculator out, right? And we're going to put this into our calculator because I'm not going to have you guys do this by hand. Make sure you guys, I'd use those parentheses to make sure that everything is staying all nice and kosher. And I'm going to come up with $12,160 and 80, whoops, it's a bad 8, and 84 cents, right? So make sure you guys are trying these in your calculator and that you're coming up with that value. If you're not, give me a little shout out so we can figure out where our glitch in the system is, okay? The second choice you have is you went down the road to another bank, and that bank sat there and said that they would pay you 6.85% interest per year. But guess what they're going to do for you? They said since it's at a lower interest rate, we're going to compound it continuously. And you're like, I wonder which would be the better choice. So to figure this one out, I'm looking at it, and guess what word I see? I see that continuous word. And since I see that continuous word, I know I need to use my continuous interest formula, which was f of x equals p e raised to the rt. And some people call it PERT. You put it in your hair, you know, nice shiny sheen. All right. So let's see what we come up with. So P is our principal. So our principal didn't change. So we're still at 8,000. And we still have Mrs. Taylor. So see, literally our principal hasn't changed. E, right? Because we know E is E. And we have a little button in our calculator for E. We're not going to put in 2.818 because that's an estimation. We want to use E on our calculator, that little button E. R is our rate, and we know that we had to change that to a decimal, so that was 0.07 times T, which is our time, and our time was 6. So we're going to grab our handy dandy little calculator.
Wouldn't the rate be the 6.85?
Oh, thank you. Yep.
Problem.
See, this is why I keep you guys around. So we get 0.0685, thank you, times time, and our time is still good. I'll put a little x there, times 6, right? Now we can put that into our fancy dancy little calculator, right? And we're technically finding
Why
f.
did you add zeros on top then?
Because it was 6.85%, right? So we have to turn that into a decimal. Yep. So that's 6.85 over 100. Yep. And I think we get $12,066.60. So should you choose option A or option B? So in this one we should pick option A, right? Sound like a plan? So biggest thing is when it comes to these problems, and sometimes in the textbook though, I think it's kind of a little bit of a downfall. They'll put all of the compounded monthly, semi-annually, biannually, all those things. They'll put those all together, and then they put all the continuous problems all together. So you get in the habit of just doing whatever you're supposed to for that little section within the assignment, and then all of a sudden it comes to a quiz or a test, and it's like, then you have to actually read because they're not categorized, you know what I mean? So just make sure you're reading to see if they're giving you a time frame or if they're giving it to you continuously, to make sure you're using the right little formula.